Hi, everyone. Thank you so much for having me, Reggie. It's a real pleasure and honor to be here. I'm very excited to speak to Dr. Anita Sengupta. She has an absolutely sterling, jaw-dropping career. She's worked with NASA. She and her team were responsible for designing the supersonic parachute that helped the Curiosity rover land on Mars. And just one statistic there, excuse me, was that she had to design something which would carry the weight of 28,800 kilograms on an object or a device that was just 45 kilos. She's worked with the cool atomic laboratory in NASA, where they're looking to create Bose-Einstein condensates, really working with extreme edges of technology, the plasma thruster that helped put the Dawn mission on the asteroid belt. And now she's been working on both the Hyperloop and through her own company, Hydroplane, working on creating an electric plane which will bring airports to our doorstep with vertical takeoffs and aerial landings. All of it which sounds like sci-fi to our ears, but you're at the thick of it. So a real pleasure to speak with you, Anita.
Morning. Nice to speak with you as well. Thank you for having me.
Yes. So, Anita, as I said, your life for us sounds like a sci-fi film, and I would love to look at each phase of that, but I'll take you back in time. To begin with, I want to sort of plunge in, though that's not the correct word to use in aviation, into your immediate set of concerns, which is to design the electric plane, and you're very interested in sustainable transportation. So, can you tell us, at what stage you're in? Overall, what stage is even the idea of electric planes in the world?
Yeah, so obviously the number one challenge that we face as a global society is climate change. And there are many sources of CO2 emissions. The transportation sector is one of them, and it's a large sector. And if you take a look at developments that are afoot in the area of cars, trains, buses, and trucks, there is electrification of those vehicles, which is easier to do because they don't have a gross takeoff weight limitation. But there isn't really that much being done in the area of aviation, and it's because it's much more difficult to do. So you actually can't have a solution for large aircraft which relies on batteries. It has to rely on something which is more efficient from an energy density perspective, and that is to switch from a hydrocarbon fuel to hydrogen as your fuel source, but not internal combustion engine, but instead using hydrogen to power a fuel cell, which then provides you the electricity to run an electric motor to support the aircraft. So it is electric propulsion, but instead of being powered with energy stored in batteries, it's energy stored in the form of hydrogen, which then goes through an electrochemical reaction into a fuel cell to generate electricity for an electric motor.
So, yeah, Anita, of course, there are a lot of professionals in this sector who are listening in, but there may be others who, for whom this is also like new conversation. So, before I go into why you are betting on hydrogen cell technology, which interestingly I saw Elon Musk says is mind-bogglingly stupid, and he calls it the fool cells. And so, I'd love to take, get your perspective on that. But before that, I just want to, you said that it's one of the biggest polluters. We have the climate change report by the ICC right now, and it's 2.4% of global emissions. So really, the plane sector is very, very important to, to make it a cleaner way of transportation. But like I said, before we go into the specifics of what you're betting on, what you're trying to create, can you spell out some of the the real difficulties? Like, are there any jaw-dropping figures that you can share with us about how tough this entire enterprise is, which would make it visible to us?
There's a lot to unpack in what you just said there, but I think there is excuse me, an engineering challenge associated with electrifying any vehicle. It's more difficult for aircraft because you have to be very mass efficient. So if you're a ground-based vehicle, like a car, like, the Tesla electric vehicle, for example, it can be quite heavy and it doesn't matter because it's traveling on the ground. But batteries, unfortunately, are too heavy to be able to support electric aircraft. So the only certified electric plane that's out there, which operates off of batteries, is the Pipistrel Alpha Electro. It holds 2 people. It's considered an ultra lightweight aircraft, and it can fly for a maximum of 1 hour. It at basically 100 miles per hour. That's the limit of what you can do with an electric airplane. So clearly that's not a solution. Therefore, you have to think of something else. And hydrogen itself is the most energy dense fuel that you can have, which is the reason why hydrogen is used in rockets, including rockets from Boeing, from Lockheed, and from SpaceX. So hydrogen is the solution from an energy density perspective.
Right. So, I mean, if you look at the core issue here, apart from the designing of the shape of the aircrafts, etc., what you just focused on is the batteries. I mean, to have energy efficiency in the battery. And I was just these are, I'm completely late to the conversation, so I'm really looking for you to help us understand this. That when I'm asking you about how feasible all of this is, I was reading somewhere that the most efficient battery that exists right now can have 250 hours of wattage per kilogram, whereas the jet fuels that we use is 12,000 hours of wattage per kilogram. So that's a massive gap. So are we looking at like a 50-year time frame in which all of this happens? You're focused on creating this, electric plane.
No.
What time frame are you looking at?
So in terms of smaller aircraft becoming airborne using hydrogen fuel cell technology, that can happen in the next few years, as in less than 5 years. In terms of jet aircraft operating off of either hydrogen in an internal combustion reaction or in a high temperature fuel cell, that technology is a little bit longer away, just because high temperature PEMs don't yet exist, which is required for high altitude flight, where you have, you're flying at altitude, which means there's less oxygen in the air. But these are technologies that, are in a low level of development for those sort of high temperature PEM applications, but they are in development. But I think I don't remember what the first part of your question was, but one thing that is a challenge for aviation is it's a highly regulated industry, which means that if you want to introduce new technology, you have to introduce it in a smaller form first, such as smaller aircraft that don't weigh as much, don't carry as many as people, and then you have to get it regulated and certified. So that does take time. So that's why I think the biggest challenge actually is probably on the regulatory front, because it's a new technology for this industry.
Right. So help us understand where you're at in your innovation. You're focusing on smaller crafts that can. Am I right to understand? That it's something that could actually take you from your doorstep to short distances, airports, little flying holiday destinations. Like what is it that you're focusing on, and where are you at on it?
So we're focusing on developing the power plant technology, and how it's implemented into what vehicles it gets implemented is there's a range of options, right? So you could go with a smaller aircraft that you see behind me. You could go with a helicopter. There are vehicles such as urban air mobility, electric vertical takeoff and landing aircraft, which are in development. It could be used on one of those. It could be used in the marine sector. It could be used in cars and buses and trucks. It really depends upon what your power needs are. And then that tells you how much power you require from the power plant itself. But for smaller aircraft, we're looking for first flight, within a year. In terms of certification, that's a little bit more difficult to predict, but certainly in less than 5 years.
So could you explain what this vertical takeoff means, and what is aerial landing? What are these terms like? Could you sort of help us understand that?
Well, most people have flown on a traditional fixed wing aircraft, whether it's a small one like behind me, or if they've flown in a jet aircraft. And so those have lifting wings. They go down a runway, they accelerate to a certain speed, you generate lift on the wing, and you take off. Vertical lift, not everybody has been on. The most common vertical lift platform would be a helicopter or a rotorcraft. Those obviously have existed for many, many decades now. There are new aerial platforms being developed called eVTOL, electric vertical takeoff and landing. Instead of having a single rotor, they can be more like a multi-copter, quadcopter type of system. And so those are also in development, but it's basically just vertical lift. So will you take off on a runway, or will you actually just take off vertically? And that depends upon whether or not you want to travel from one city to another city, or if you want to travel within an urban suburban environment. So the vertical lift is only required if you want to travel within an urban suburban environment. But for most aviation use cases, you wouldn't use that kind of platform. You would use a traditional fixed wing aircraft because they're more energy efficient.
Right. So, you were laughing about the first half of my question. It was that of all the sort of battery technologies, to my understanding, you said regulation is one big challenge. And then the other is about how to create really efficient batteries that are have enough energy, that are rechargeable, as Reggie said, that will also have a grid, where people can refuel. But I wanted to ask you, of all the competitive battery technologies out there, why have you focused on hydrogen fuel? And why was Elon Musk criticizing it as fool cells or mind-bogglingly stupid?
Well, I don't know where that quote comes from, so I'm not going to comment on that quote. But we're interested in hydrogen fuel cell technology, which is an electrochemical reaction. So it's basically an air-breathing propulsion system in the sense that you carry hydrogen with you as your fuel source, and then you get oxygen from the air. So it's a very efficient way, right? Because you don't have to carry the oxygen on board; you get it for free from the air. So batteries have a use in stored energy, but only for ground-based applications. They're simply too heavy to support an aviation application if you want to fly for long distances or carry large payloads. So it really depends upon what your mission is. But if your mission is to fly for more than an hour, or if your mission is to fly more than a couple of 100 kilometers, you could never do that with batteries because they're too heavy. So the battery use case is appropriate for urban air mobility, for short transits within a city. It isn't a solution for the traditional aviation use case, which would be traveling between cities or traveling between nations or across land masses or across water bodies.
Right. So, you just said that this actually just sidesteps the whole issue of heavy batteries and dead batteries in air or in on land transport. So then what is the challenge at all in using hydrogen fuel? Like, why is everyone not focused on that? And what is the grid challenges on that?
So the challenge with hydrogen is how it's stored. So the way hydrogen is used as a fuel for launch vehicles is it's stored as a liquid because that's more volume efficient, more mass efficient way of storing it. For cars, for example, like I have a Toyota Mirai, for example, it's stored as a high pressure gas, which is okay. It may be heavy, but it's a car, it's on the ground, so it doesn't have those gross takeoff weight limitations. For aviation application, you have to think about how it's stored, and it's likely that high pressure gas isn't the solution. There are chemically bonded methods of storing it, and there's also storing it as a liquid. And so the big challenge, I would say, for aviation specific application is how to store it on the aircraft so that you can get a lot of fuel on board so you can travel long distances. I would say the larger issue for hydrogen altogether as an energy carrier is its production. Now, hydrogen is mainly made by a hydrocarbon reforming process, which obviously has a CO2 output associated with it. And so to have green hydrogen, you want to produce it using electrolysis, which has electricity, which comes from a renewable source. So actually having enough renewable electricity, whether that's from solar, wind, geothermal, to provide electricity to an electrolyzer to create green hydrogen is probably the biggest challenge because that's an infrastructure challenge, that's an infrastructure investment challenge, and that's something that governments have to decide to do, right? So the argument here is that you would shift over from hydrocarbons to hydrogen as the energy carrier of choice because it is carbon neutral in the sense that you don't get CO2 as an output from either burning hydrogen and oxygen in an internal combustion reaction, the byproduct is water, or hydrogen and oxygen in a fuel cell, the byproduct is still water.
Right. So, before we shift focus a little bit, Anita, what interested you in, it's been a kind of lifelong passion for you. Was there any trigger moment, any incident that got you so interested, particularly in transportation, and then over the years in sustainable transportation? What got you interested?
Well, I spent the majority of my career working for the space program, which was very exciting and important. And I think the scientific discoveries and the technology follow-ons that come from the space program cannot be measured in any way. They're so impactful on society. But I wanted to do something in the second half of my career, which was more focused on solving technology challenges associated with climate change. I'm a very active pilot myself. I also fly a lot for business. And so I would like to be in the driver's seat or in the pilot seat to decarbonize aviation. So it seemed like a good way for me to be able to make an impact. I did actually spend a few years in the battery-powered eVTOL space. And in designing those vehicles, I saw how limiting they were because batteries simply couldn't do the job to provide meaningful aviation range. And so the reason why I started a hydroplane was to actually develop the needed technology to decarbonize aviation for the whole range of aviation use cases, meaning larger payloads and longer distances that you would want to travel in an aircraft. So I really wanted to be a part of the solution.
Yeah. In fact, just to help people visualize, the scale of the problems that you're trying to solve, I read a very interesting nugget somewhere, which was that, the Boeings that we use, if we were to try to replace that into electric planes, one would need 1.2 million pounds of a battery, which would need another 8 Boeing planes just to carry the weight of that battery. And so, like you said, the really long distance passenger flights, it's a very long time frame. But that kind of crystallized for me the sheer magnitude of problems that you're trying to solve and design. And it may be for smaller planes, it's less difficult, but that's what you're really grappling with when you're trying to electrify aviation. So I found that very interesting. So, before I move to, sorry.
The one thing I will say though is, which is an important point, is that for the most part, people have focused on internal combustion as the means of getting energy out of a fuel. The reality is an electrochemical reaction is a far more efficient way of getting energy out of that fuel. So the challenge then becomes in lightweighting the fuel cell technology to take the benefit of that more efficient electrochemical reaction. Because with internal combustion, you end up losing a lot of your energy as simply heat, waste heat that you don't use. Whereas in the electrochemical reaction, which is what a fuel cell is, you get a lot better efficiency in terms of the energy contained in the hydrogen gas molecule and actually getting it into kinetic energy to move your vehicle. So it's actually the right engineering solution, but you then have to design the fuel cell technology and the balance of plant to make that work. So it is an engineering challenge, but it's one that can be solved.
Yep. So, just talking about grids and government support, if you don't go to the other batteries, which is of electric batteries and recharging, which takes a lot of time, etc. For this hydrogen fuel technology, what is the governmental support? You mentioned about clean hydrogen and through green technologies of generating hydrogen, but in terms of just grids and fueling stations and things, what is the infrastructure that this technology would need?
So it's probably the most difficult thing to shift over from gasoline, from hydrocarbons, to a new energy source is the infrastructure required. So we've seen infrastructure being put in place to charge electric cars, which are powered by batteries. That in California, where I live, there's actually no shortage of places to charge your electric car. I can't speak to the rest of the world. It's probably not as much. In California, we actually have hydrogen fueling stations. So I can fuel my hydrogen-powered car down the street from where I live. But that's only in California because the government of California has decided to make an investment in those technologies. So it's absolutely required for federal governments around the world to recognize that they have to provide that infrastructure, both to charge the vehicles or to fuel the vehicles, in addition to the energy to provide electricity to the electrolyzers to make the hydrogen. So I think the larger challenge probably isn't the fueling station or the charging station. It's actually making the green energy and the cost associated with that infrastructure project so that you have enough electricity, green electricity, to create that hydrogen. And so there's a huge cost associated with infrastructure that I worked for the space program my whole career. And then when I left to go work for the Hyperloop, I saw how much more expensive an infrastructure project was than, for example, James Webb Space Telescope. It makes James Webb Space Telescope look inexpensive.
Oh God, that's an interesting data point you just said. That just transforming to clean energies is more expensive than the space program. Wow, that's a true magnitude of problem. Just one more thing, which I'm sure people would be interested in, Anita, when you're saying that this might look like a 5-year time frame, that's so imminent. That what is the length of distance that, say, hydrogen fuel can how much can it sustain? Are we looking at 100 kilometers, 500 kilometers? What is the range of flight through this technology?
So it really depends upon how much fuel you have stored on board. And so obviously a larger aircraft could store more fuel on board, but we're targeting for our first implementation, between 500 to 1,000 kilometers, which is a good distance to support regional travel. So we're really far away, obviously supporting, transoceanic travel. That's really, downstream. But in terms of a 500 to 1,000 kilometer range, that can support the regional marketplace. And when you take a look at the aviation marketplace, the majority of CO2 output actually comes from regional travel, not from oceanic travel. So the right way to actually make a dent in the CO2 which is being produced by the aviation sector is to target that regional market.
Right. And just one last, could be a really dumb question, but what is the shape of these, Anita, when you look at this technology and you look at the future of transportation, things that we see in sci-fi movies, which are like literally like pods, is that the kind of shape that you're designing, or are we looking at like more helicopters and traditional plane shapes? Is that an important factor of this innovation, the shape of that vehicle?
So in terms of a fixed wing aircraft, the shape is an aerodynamic shape, right? So an airfoil for the wings and a streamlined body for the fuselage section. So then the challenge becomes, how do you store the hydrogen fuel on board the aircraft? Do you store it as a gas? Do you store it chemically bonded? Do you store it as a liquid? And then where would you place those tanks? So the good news is that if you do store it in a liquid form, you can make use of existing space on existing aviation platforms. So I think you're probably more focused on this urban air mobility space where you see these interesting rotor systems. I'm not referring to that. That has a very different use case. That only refers to travel within a city, or maybe within a city in the urban surroundings. So for the majority of aviation, you'll still always do that on a fixed wing platform, which can be the jet that you currently fly, a twin turboprop, or a single engine aircraft like you see behind me. So it actually doesn't change the shape of the aircraft, which is good, right? Because why would you reinvent the wheel if you don't have to?
Right. Now, again, just to share with the audience of the importance of what you're engaged with, in terms of climate change and carbon emissions, just one flight from London to California and back is one person generates more, carbon emissions than what a family would use, twice what the family would use in a car. So, the fact that you're focusing on this sector is so important, because also air travel is looking to spike by manifold spike in the years to come. So it's only going to increase, our carbon emissions through aviation. So
It really depends on how you present those numbers, though. But when you look at CO2 per passenger kilometer, commercial aviation travel, which is transoceanic, is actually far more efficient than a car. If you look at it per passenger kilometer, CO2 is a lot less. So the least efficient way you can travel is as a single person in an SUV in terms of your per passenger kilometer carbon footprint. So anytime you have mass transit or shared transit, you share that CO2 between a larger number of people. That being said, the only solution for decarbonizing all forms of transportation is to get rid of the CO2 altogether, right? Which means it requires these new technologies. But when you can find synergies between technologies, when you can find synergies between energy, right? If you're creating green energy on the grid, which can be used to charge your battery powered car, or can be used to run an electrolyzer to create hydrogen for an airport, that's synergistic. That means the government is investing once in something which solves a range of decarbonization technologies.
right. One last question on this before we move to, the space innovations that you've done, Anita, is that you spoke of the challenge of generating clean electricity. It's a more expensive proposition than, say, putting the James Webb Telescope in space. But in the meantime, in the interim, if one was even using existing electricity, is that plausible? And can we even generate enough electricity through traditional methods? There's so much innovation about electrification, but the source there, electricity itself, is the problem. Generating electricity is the biggest source of fossil fuels being used. So how do you see that conundrum being sorted?
Well, I think the solution to generate electricity using green means, whether that's solar concentrators, or wind, has to be done, whether or not you're using energy for the transportation sector, or you're using energy for home heating, or businesses or manufacturing. So that's a solution that has to come for everybody. So it's almost you don't have a choice. We have to do that, right? Otherwise, we're going to kill the planet. So to me, it's not relevant that it's difficult to do, because it has to be done. The good news is that when you can find other people who can make use of that green electricity electricity, right, to further eliminate reliance on hydrocarbons, in the end use in the form of a car, that's a really good thing. So it actually helps to justify why government should invest more in these green energy projects. But I think cost always makes things, harder to implement. The really great part is that right now in California, it is the same cost to fuel your hydrogen-powered car per mile of distance traveled, right, in terms of like fuel economy, as it is for your gasoline-powered car. And you know that the cost of hydrogen is going to drop precipitously. So very soon, it will be much cheaper to operate your car and to operate your aircraft off of hydrogen than it is off of hydrocarbons. And so at the end of the day, you can save money.
Right. On that point, this is just lay people's reading, but tell me if I'm correct on this data point about costs, that there was a successful flight of the E-Caravan, and that it was, of course, a short flight, but that it cost $6 of using hydrogen fuel compared to what would cost $300 or $400 for a similar flight. Is that like the correct price difference if one manages to crack these technologies?
Well, I'm not familiar with that flight, but I am familiar with how much it costs for me to for me to refuel my hydrogen-powered car, and how much it is for me to refuel my gasoline-powered car. And it's identical in California. There's no difference. And right now, hydrogen is at its peak in terms of cost, so it's only going to come down, and the price of gas is only going to go up.
Right. So let me take you for a moment to, like I said, backwards in time, actually, which is the forefront of the research you've been doing in space technologies. You were very responsible for designing that parachute that landed the Curiosity rover on Mars, and helped it transit through this 7 minutes of terror. Can you tell us what that is and what was the challenge in designing that?
So one of the types of, I guess, multidisciplinary areas that exist in the space program is entry, descent, and landing. And that's how you enter a planetary body that has an atmosphere, use that atmosphere to slow you down so you can safely land a payload on the surface. In the case of this Mars mission, the Curiosity Mars Science Laboratory, our payload was landing a rover on the surface of Mars. And so you're coming in at very fast speeds, and then you use the atmosphere to actually slow you down using aerodynamic drag. So it's like the exact opposite of what you would want to do with an airplane, right? Which is to be low drag. In this case, you want to be high drag to slow yourself down. And when you're going in that environment at those fast speeds, you experience extreme G-forces, you experience aerothermodynamic heating. And so there's a lot of extreme environments that you have to design to be able to tolerate it. And you also have to be very mass efficient and volume efficient. So ironically, a lot of the approaches that you use to design a complex system for an entry, descent, and landing mission can also be utilized to design complex systems here at home to make them more energy efficient, to make them more mass efficient, to be able to tolerate difficult environments. But of course, multiple Gs that you experience on entry on Mars or re-entry on Earth is a lot more difficult than what you would experience in an airplane here on Earth.
So, how long did it take you to do that? And that one data point that you're balancing that amount of pressure on something so tiny, how long did it take you to design that, and how many people were involved? You were heading that entire project. So give us some of the, the sort of the over dinner talk that you can share with families, the things that make it visible in terms of just what you achieved in that project.
Well, so I was responsible for the supersonic qualification for the parachute, which was one technology of many technologies which is used to do the entry, descent, and landing on Mars. I also worked a little bit on the sky crane, so there was probably several hundred people working on the design of that system from end to end, probably more than several hundred people. And overall, the development took us about 7 years, which seems like a long time, but we experienced a loss or a missing of one of our launch windows, which means it got delayed by 2 years. And there's a lot of testing and analysis which has to be done to show that each part works in the environment that is expected. And then eventually you piece it all together in an end-to-end simulation. That being said, this wasn't the first time that we had landed on Mars. There had been prior successful landings on Mars. And so you leverage from the prior times you've done it successfully, and then you land something with more precision, you land something which is larger, you land something which has more scientific capability, and so then you're kind of pushing the envelope of what you want to do the next time around. But Yeah, it typically takes between 5 to 7 years to design that type of system with many hundreds of people involved.
And just this, 7 minutes of terror, what does that mean? And again, what was the challenge of overcoming that 7 minutes of terror?
So when you are landing something on the surface of another planet, which is far away from Earth, there's a pretty large time delay. So that means it has to be done autonomously. It has to have the ability to sense its location, its speed, its attitude, and correct so that it can land safely on the surface. The 7 minutes is basically the time from when you enter the top of the atmosphere to when you safely land on the surface. And so that process starts with a hypersonic phase where you decelerate through the upper atmosphere using something called a heat shield. So you experience extreme heating because of friction with the atmosphere and multiple Gs. You then go through a supersonic phase where you deploy a large parachute, which is a large aerodynamic decelerator, which takes you from 2 times the speed of sound to subsonic speeds. At that point, you've essentially reached terminal velocity, which means you can't go any slower. So you then cut away the parachute and you do the remainder of the descent using retro rockets to slow you down as you approach the surface. And then ultimately you want to land pretty softly at only a few meters per second. And so that very final landing stage was done on a system called the Sky Crane, where the rover itself separated from the propulsive platform above on a set of 3 tethers and eventually touched the ground. And when that touching of the ground was sensed, wheels of the rover on the ground, the tethers are then cut, and that propulsive stage separates and flies off to the side. And of course, the challenge there is that you are dealing with a different gravity environment, a different atmosphere, extreme G forces, extreme heating loads, and of course, all of that has to be done autonomously with no human being in the loop. So it requires you to have a very robust engineering design, a active control system from a guidance, navigation, and control perspective, and there are many other technologies I didn't talk about in there which allow that to happen. And we've been doing that type of system, if you can believe it or not, different variations of it since the late 1970s. And each time it's been done, we've got better computational capabilities. We have better models to define what the atmospheric properties are, and then we can do it better and better, and so we can increase the precision. So with the Curiosity rover and the Perseverance rover, we were able to really reduce the landing precision, improve the landing precision so that we could land in a more interesting location from a scientific perspective.
Right. So, of all the other, you've been involved in designing the Hyperloop or in increasing its efficiencies, and also on this laboratory, the Cool Atoms laboratory, which is really at the cutting edge of technology. So, if you would pick for you, the most sort of exciting or cutting edge thing that you've done, what would you pick?
They've all been really fascinating and enjoyable. And actually, my PhD research might have been one of the most interesting just because I was so intimately involved with redesigning this engine. And that's actually helping a lot in my current project, which is related to having a more efficient fuel cell. But they've all been really fascinating and exciting in different ways. And when you start off in your career, obviously you're more on the analysis side, on a smaller experimental side. And as you progress, you become more in a leadership role. But each of them have had amazing growth opportunities for me intellectually as well as from a leadership perspective. So I couldn't pick one. I think they've all been really fascinating. And I'm such a fan of engineering and pushing young people to be engineers, for example, because it's such an exciting career. But I would say I feel as though what I'm doing now is more impactful because I can do something to help reduce our anthropogenic our footprint, our carbon footprint on Earth. So I think that's really important. And I would say my space program training has actually set me up to be able to do this.
So, when you, I'll still take you back to that because it just sounded so fascinating, what you're doing with those chemicals and those condensates and what is the impact for that for man, your discoveries there. But before that, I wanted to ask you that when you're an entrepreneur now and you're the CEO of Hydroplane, is this all this research, is it funded by governments? Is it by the private sector? Are you putting in your own money? Just in terms of for an Indian audience, the whole innovation and entrepreneurship here, it would be interesting to understand where's the funding coming from to drive all the innovation that you're at the heart of.
Yeah, so we have a combination of government contracts. So I obviously am a research technologist, so I can write good research proposals and get funding from the government, and also private investment from angel investors who are interested in decarbonization technologies. So I think if you are going to be in the green tech space, you can probably get a combination of government grants, government contracts, as well as private investment, either from angel or from venture capitalists. So I think it's kind of a combination of all of those things, but you also have to have a good business justification, right? Because at the end of the day, even the government will invest in you because they see the opportunity for commercialization, which can help stimulate the economy. So it all really does come down to economic input and impact at the end of the day. And then you also have to think about your customer, like your end user. And so for aviation, of course, that could be the flying customer, it could be the aircraft owner operator, or it could be the pilot. And if they're looking for ways to reduce their carbon footprint and reduce their operational costs, that's a win-win too. So you got to really think about ultimately what it is your ultimate customers need and make sure that you're meeting those expectations. But I think everyone should have a responsibility these days to engage in activities which are socially responsible. And so I think if you are planning on becoming an entrepreneur, I would encourage you to focus your ideas and your innovation in a way which is socially responsible and can help the planet and help people from all walks of life around the world.
So, Anita, you are of Indian origin. You have a Bengali mother. That when you're looking, are you at all closely watching or engaged with the innovation space here in India? Whether it's ISRO or transportation or focus on green energy. How excited are you or hopeful are you about the Indian scenario? And are there any inputs that you'd like? There'll be influential people watching this. What are some really important inputs you'd like to give about what we should be doing in India?
Well, my father is Bengali,
Sorry,
and he
Sengupta.
was a PhD mechanical engineer, so I kind of followed in his footsteps in that sense. And I did have the opportunity to go to India quite a bit before COVID, so giving presentations to students. And I actually went to Israel and gave a presentation. I went to a local startup in the vicinity of Israel and gave a presentation. So I'm really hopeful to be able to come back again, after travel becomes a little bit easier, to continue doing that. But we would love to be able to partner with India in our aviation sustainability initiatives, whether that's working directly with airline operators there who are looking to have lower carbon footprint in their vehicles that they've purchased, or working with local researchers who are interested in this area from a balance of plant perspective, or from a fuel cell perspective, or even from an aircraft design perspective. So I think this is a solution that we need across the world. It has nothing to do with the United States or Europe or India. It's about all of us as earthlings, as human beings. So I'm looking for opportunities to collaborate for sure.
And I had also asked whether you're familiar with the ISRO program, and how does it stand in the world's eyes in terms of how well and advanced the work that's being done over here is.
Yes, I'm very familiar with Israel, and I did have an opportunity to visit a few years ago and give a seminar when I was there, and meet several of the leading scientists there, many of them women. So it was a
Yes.
fantastic experience. And I am always amazed by the innovation and the cost efficiency of, for example, the Mars orbiter mission, right? The cost to be able to have the launch vehicle, as well as the operations, as well as the spacecraft, and to do that so cost effectively is a tremendous innovation. And so India should be very proud of that, as well as very proud of its launch vehicle program. And so I think that space is meant to be a global endeavor. If we really are going to put people on Mars, it's going to be an intellectual collaboration. And I can see a lot of opportunities in that area for ISRO to be involved from the launch vehicle side of things, as well as from the spacecraft development side of things. So I tend to view the world as a global entity. I don't really think about it in terms of, basically what space agency I kind of, because I have different ethnicities myself, and I was born in the UK, or I live in the US, but I have Indian family members. So I only see kind of those international collaborations as the solution to our challenges, as well as to creating a much better future.
So, Anita, just your passion is just like, it's literally spilling out of you, and yet, while one doesn't want to constantly look only through the prism of being a woman and of, of having Indian origin and all the kind of, sort of hurdles that implicates that you have crossed, But still, it's exciting to ask that it's not so common to see women really in the heart of technological spaces and breaking boundaries. That where did your passion begin? You mentioned your father, but this fascination for space, etc. Did it come out of books, movies, someone inspirational you met apart from your father? What was the origin of your enchantment with this space?
Well, my dad and I used to watch Star Trek together. So I've always been a huge science fiction fan, just like my dad. And so I think science fiction probably impacted me in a pretty significant way. Just kind of seeing this other future where people exist to discover, exist to better themselves, and they don't focus on materialism and things like that. I think that's kind of always driven me. And it is unfortunately, still rare to see women in leadership roles in the aerospace sector. It's even rarer to see women as entrepreneurs in the aerospace sector. I think there's not very many of us. But to be honest with you, that drives me to want to do it more because I want to make, I want to trailblaze for all the women who come next.
Yeah. So you just mentioned about, Star Trek, that sitting here today, at the start of 2022, in a 5-year span, in a 10-year span, can you do some crystal projections of how we will see our environment change, which we can't even fathom right now?
So I do think that there will be a cessation of reliance on oil and of hydrocarbon fuels. I think everything absolutely will shift over to renewable energy, which means the grid, which is the topic of this conference, is probably one of the key parts of the infrastructure development to make that happen. Because when there's a larger load on the grid from everybody who's using it, for everything from home use to business to manufacturing to transportation, that all of a sudden becomes like the tall tent pole to making this all work. But I do see us going to be 100% renewable energy. I'll see complete removal of anybody using oil to power their vehicles and to burn it, right, to generate electricity. And I also see a more circular economy model where people come up with ways to be able to reuse things in different types of supply chain. And I also see much larger reliance on virtual interactions and meetings. And so I think if COVID had any positive impact on human society, it was that we don't have to go from point A to point B to be able to do our business, to have our interactions. We still should in some ways, but in large part, we should do everything that we can to reduce our carbon footprint. And so I think that's kind of the future I see, where we're more responsible in the way we create our energy and we use our energy and we share and utilize our resources. But I see us becoming a far more global society, which helps because now we have all of these wonderful tools, such as virtual meeting places like this to be able to have that global society.
Right. Just, I see some hands, and we're going to run out of time soon. That when you speak of the grid, in this whole basket of clean technologies, you've so focused on the use of energy and new energy technologies. Where would you sort of lay your bets? In that whole pie, where should the focus really be? What should that basket look like?
So I mean, it may not be the answer that you're looking for, but it actually is an energy production. So energy production is the key to everything. And so when people can say that we need this much green energy production because this much use, which is coming down the pipeline, that's the solution to everything. Because without that energy production, we can't have any of these downstream use cases of that energy. So I would say governments, policymakers, everybody needs to focus on green energy production and those projects to make that realistic. But they have to be efficient. And so I think what I've noticed quite a bit of as somebody who's not on the infrastructure side is you have a lot of these projects that don't go anywhere, right? They'll make this big solar concentrator facility or big wind farm, and then it's so expensive to operate, then it's not even used. And that's wasting the public's money. So when you do have these projects, they have to be done responsibly, they have to be done efficiently, they have to be done cost effectively, because that will make them sustainable in the long run.
So is when you're saying that the big challenge here always is cost. Just to loop back to you, that this innovation that you're attempting, do you have a kind of price point that you think will be feasible, and what is that price point that you're working towards?
So we have to be identical to the price point of internal combustion engine equivalent, right? So if you buy a hydrogen car, a battery car, or a gas powered car, if it's all the same price to purchase up front, that's the right solution. If it's the same price or cheaper to operate, that's an even better solution. And so when it comes to electrification of vehicles, the price point of the unit vehicle is the same, you're great, you're done. If it's even cheaper to be able to maintain it, you've got to win. If it's cheaper to be able to operate it, you've got to win as well. So ultimately, you want to be more green, more clean, more energy efficient, as well as lower operations costs, which is inherent in this electrification model.
So you were involved with the Hyperloop. There was a lot of excitement about or anticipation about the Hyperloop even coming into India. Do you see that as an important aspect of what should happen for ground transportation? And, and there's a second question, which is that quite often these technologies create also a lot of resentment and hostility that this is very elite and, there's so much money being spent on stuff which could be better used for the masses of humanity. How do you see that debate? So one, what is the importance of Hyperloop and this debate about so much money being spent on what is seen as elite, whims, perhaps?
Well, so I never really thought of the Hyperloop as anything other than a form of mass transportation on the ground, just a more energy efficient way of doing it. So whether you start off with a high-speed rail, a maglev system, or a Hyperloop, it doesn't matter because it's mass transportation, it's shared transportation, and if long as it's affordable for everybody, then it's a good solution. So if you want to start off with a high-speed rail, then shift to maglev, and then eventually get to the Hyperloop, I think that's fine too. It almost doesn't make a difference. And because all of those ground-based systems are run off of a catenary, or they can be run off of the grid, right? And you can even have a system which is generating its own power with solar panels along the route so that it's completely carbon neutral. So it doesn't really matter to me whether or not it is, a light rail, a metro system, Hyperloop, high-speed rail, maglev, as long as it's affordable for regular people to use it, then that's the right solution. If there's a solution which isn't affordable for everyone to use it, then it's the wrong solution, right? Because accessibility is the key to adoption.
Right. So just, about this whole space program and how expensive it is, you were just saying that what Star Trek inspired in you was just that, fascination and the energy of discovery, which is not really material, which may not even seem pragmatic at that moment, but it's just discovery. So, like I was asking you about the Cool Atom lab that you are so involved with, or say Elon Musk's space innovations that he's trying. What do you think? What are the discoveries? How do they actually relate back to man? Can you transmit some of that excitement? What are the implications of that?
So one of the questions that people like to bring up is like, what did the space program do for you? So when you innovate a new technology, you're not doing it because 15 down the years from now this particular integrated circuit is going to solve this problem. You actually don't know, right? But the innovation leads to all of these other innovations which kind of cascade from it. And so, I mean, the best example would be telecommunications, the ability to have mobile telecommunications, to be able to have Wi-Fi everywhere, which then facilitates connectivity, which can reduce our carbon footprint, which improves the quality of education for people around the world. So you can't really predict those kinds of follow-ons. And another really great example, which I think couples nicely to the Cold Atom Laboratory, is when lasers were first invented. People were like, what on earth are people going to use lasers for? A coherent beam of photons. Lasers are used for everything now, from medical purposes to manufacturing to devices that you use in the office space. You really can't predict those things, but ultimately letting the human mind explore the limits of what it can do usually results in great things.
Right. I think Reggie's come on. We need to open it up to questions. Just as a woman, were there really active challenges in your being accepted in this field? Can you talk of maybe just one incident which you had to overcome and which would be a source of inspiration for others wanting to become pioneers in this field?
Well, to be honest with you, it's a daily challenge. There isn't just one incident, but I think where I benefit is I have a many decade-long career of very successful, complex deliverables, which I can always point to. But I experience it almost any day. If someone didn't know what my background was until I informed them of what my background was, they probably wouldn't treat me the same, right? As being a woman and a person of color, in the country that I live in. So it is a challenge, but at the same time, it makes you stronger. It makes you more resilient. And it makes you try a lot harder because you want to be able to show people what you can really do.
Thank you very much, Anita. I mean, I could, sit here talking to you for another hour, but I think there'll be questions. And thank you, really. It was very inspirational. And the sheer speed and excitement with which you speak is an indication of, how in 5 years our world is going to change, because that's the kind of passion and intelligence driving this area. Thank you for sharing your thoughts with us.
Well, thank you for having me and for the interchange. I appreciate it.